Good morning or afternoon, kids. We're going to be talking about a couple things right here for segments and distance. We're going to be taking a look at a couple of things. First off, we're going to take a look at something called the Ruler Postulate. Remember, postulates are anything that is taken to be true without a proof. Proofs go ahead and work through the math and the rules and everything to make sure that everything is going to be true for that particular theorem. Theorems are proved. Postulates we take for granted and say, yes, it's always true. Okay, so we're using something also called the segment addition postulate. Plot lines on the XY plane. We know how to go ahead and plot that sort of thing. Looking back at this particular assignment, actually at the warm-up. First, we go ahead and put down where the points are. So -4, 4 units to the left, 2 units up. So we have right here. And if we draw a line segment between those two, or we extend, we have a line. So, and then we can go ahead and draw or measure it if we have just the segment. All right, so finding distance on the coordinate plane, actually it's a derivative of what we call the Pythagorean theorem. You guys should remember that. Vocabulary for this class, distance. That's the unit of measurement between 2 points. Of course, measurement, we have a couple of things. One-dimensional coordinate system. You remember this guy. We have the number line. We have units all the way around right here. Usually -1, -2, -3, and all that side. Congruent segments means that the segments are equal to each other. That's what congruent is. Alright, so that's about it for that. I'm going to go ahead and say this right now, and I mean it now and forever. There's no such thing as negative distance. No such thing as negative distance. But if you look at a number line, you'll notice that it has some negative numbers. Let's see, let's go ahead and talk about that right here. So right here we have -1 right there, -2, -3, -4. But Mr. Solis, okay, well, we have 0, 1, 2, 3, and 4. But Mr. Solis, there's negative numbers on the number line. Yes, of course there's negative numbers on the number line. This tells us location. Away from the center or from 0. So, because of that, we can go ahead and say, well, we're here at position -2 or -3 or even position 3 or 4. But the distance is the actual distance away from either 0 or from one point to another on this number line. So let's go ahead and explore that a little bit. Okay, so right here, term. Let me go ahead and use this. Okay, so line segment. Part of a line. Okay, so that takes care of that. The one. Consisting of 2 endpoints. And all the points in between. I think that does a little bit better than having to go ahead and write it on the screen now, doesn't it? Okay, so right here we have an example of this. Whoops, it still does that. I have to kind of trick it. So we have a couple of endpoints right here, and then we have the line segment itself. How to name this? This is going to be line segment AB. We have to have that symbol for line segment right there. Now right here, construct. Use a straight edge and a compass to duplicate this, to duplicate the line. So I'm going to go ahead and grab my compass here. So here's a compass. This is how you position it at the first point. We're going to go ahead and open the compass all the way until we reach the other point. Then, keeping that compass open the same amount, we'll go ahead and do this. Then we go ahead and draw that arc. Let me redo that again because it's a little bit too big and I drew over the stuff in the next segment. Now, let's go ahead. Get rid of this guy. The cool thing about this is if I draw a segment anywhere between point C and this thing right here, which I'm going to call this arc because it's a little bit of a curve, it's all based off of circles. All radiuses in a circle are equal to each other. Because they're equal to each other, we can draw from this point over here. I'm going to go ahead and use my arrow because it'll show it. From this point right there, all the way to this right over here. We can pick any point along this arc. So first off, let me go ahead and get a straight edge. There's one. Hopefully it came out. I don't know. Yeah, there it is. Move it down. Okay, so then we go ahead and take this, line it up. That's a pretty good line right there. I'm going to grab a pen, and then we're going to have to just draw it right there. And there we go. And this segment is the same as this one. So we can go ahead and take that for granted, just say that, and just leave it at that. All right, let's go on. So now for segment addition right here, so let's go ahead and see, we're finding the distance between points -2 and 6. -2 is right here, 6 is right here. So we can do this one of two ways. We can either count the number of hashes between 2 and 6. So we always start at 0 at where we have -2, and we just count 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units. Now, I know we can go ahead and take advantage, just leave it at that, or we can actually use the formula that we have. Distance is equal to absolute value of x2 minus x1. And that'll go ahead and work for us. So this right here would be x1. This is x2. And then we just go ahead and work with what we got. So we have 6 minus -2. The good thing about this is that if we take a look at this particular problem, we have negative times a negative. Negative times a negative is positive. So we have positive 6 plus 2. This is not a 1, and this is not a 1. Just remember that means that whenever we have those two lines like this, that's absolute value. Usually I'll make it a little bit longer, or I'll just say it. So this would be 8. So that's just it, 8. All right, so let's go ahead and move on. We can do this right here. In the example, you read PQ. Whoa, what happened to you? Every so often, just acts up, just jumps. Don't know why. Oops. Okay, so then again, let's try to take a look at it again. So let's see. In example 2, you read PQ as the length of segment PQ. So we're going to take a look at PQ. So we're looking at the length of this segment. Oops. I'm looking at the wrong one. Sorry. So PQ is right here. And we can either count or we make sure. Now, we don't really see this, but that's a -3.5. So you have to be very careful. And then over here, we have -2. So we're going to go ahead and use the formula. This is x2, or x1. This is x2. So it's going to be -2 minus -3.5. And there's absolute value of this. So this becomes a positive 3.5. So this has a distance of 1.5 units. Okay. If you look at the same thing for the next one, RQ. So let's see, we're looking at R to Q, which would be right here. So again, that is going to be 2.5 here on this particular assignment, or this particular number, minus -2. And so that's -4.5. Ooh, running out of space. Okay, and that's about it for that. All right. Let's go ahead and move that a little bit. I need to go ahead and take a look at this. So this right here, we're going to be talking about a postulate that we always take to be true no matter what. Let me grab this. There we go. So this is something called the segment addition postulate. Wow, I actually spelled it right today. Okay, so when you look at a line, we're going to be presenting you with a line, and it's going to say something like this. Let me see. Or it's going to be something like this. Point X is between point A and point B. Just like that, or almost like that. Wow, I'm running out of time. So let's see. We're going to have a line like this. We have endpoints A and B, and X is somewhere in between. So we're just going to put X right here. And so what this means right here, that we have this unit, we have all that. So in the segment addition postulate, we have A, X, and addition means we're adding these two segments together. So right here, we have plus XB. That's equal to the entire segment from A to B. So trust me, this is going to work for us. This is a really easy way of doing this particular types of problems. Let's see. I'm going to need to get rid of some stuff so that way I can see things a little bit better. I should have done this earlier, but you know what? Unfortunately, we just don't think about these things all the time. All right. I say we because I mean me. Okay, so right here, according to this, it says the same thing. If B is between A and C. So on the segment, we have AC. B is between it. So we have AB plus BC is equal to AC. So let me see. AB is 4, so this will be replaced with 4 plus BC, which is 5. And that's equal to AC. So we add these two numbers together. So 9 is equal to AC. This is 9. Next example, so it's almost the same. Again, they use this, so we can still use, it jumped again. Why does it do that? We can use these particular numbers. Okay, unfortunately, we got that erased. Okay, so we're going to be using that part of that segment addition postulate again. Let's change colors. Okay, so we have AB is X, so we have X in place of AB, plus BC, which is 2X plus 6, which is equal to 5X minus 14. All right, so let's go ahead and do this real quick. So this is going to be 3X plus 6 is equal to 5X minus 14. Subtract 3X from both sides. So they end up with 6 equal to negative 14. X. Oh, no. I messed up a little bit. Sorry about that. I apologize. Okay, so this is 6 equal to 2X minus 14. We add 14 to both sides. That's 20 equal to 2X. Divide both sides by 2. So X is equal to 10. Now, right here, we're going to be answering these two parts right here. So they're asking what AB is and BC. So AB is equal to X. So AB is equal to 10. And BC is equal to 2X plus 6. So we have 2